Hi and welcome back. It was brought to my attention that there was no video for the very last Roman numeral here in Applications of Linear Equations and Modeling. So here we go. Roman numeral 3, create linear functions to model data. Okay, linear functions can sometimes be used to model the cost, revenue, and profit of producing and selling X items. And it looks like here we have the little box that's in the book. For linear cost, revenue, and profit functions. What is a linear cost function? It models the cost to produce X items. If your cost function is linear, then you're going to have what's called a fixed cost, and that's the cost that does not change relative to the number of items produced. And it's going to be over here, it's going to be the B. So for example, if you have to pay for rent for an office space, that's going to be a fixed cost. But you also have what's called a variable cost. So the variable cost is going to be here attached to the X, and it's the cost per item to make. Let's say the materials per item cost you $5. So you would have 5X here. Okay, you also have what's called a linear revenue function, and it models the revenue for selling X items. That's the money that you bring in. So the product P times X represents the price per item, P times the number of items X. So if you say it cost you $5 an item to make it, that would be in your cost, but let's say you sold each item for $10. So your revenue would be 10 times X. Then you have what's called the linear profit function, and it models the profit for producing and selling X items. What I always remember is that profit is equal to revenue minus cost. How much you make minus how much it costs you to make it. Sorry, how much you make when you sell it minus how much it costs to make it. So now let's look at an example. At a summer art show, a vendor sells lemonade for $2 per cup. Okay, that sells lemonade. So that's going to be part of the revenue, the money that you bring in from selling it. The cost to rent the booth is $120. Furthermore, the vendor knows that the lemons, sugar, and cups collectively cost 50 cents for each cup of lemonade produced. Okay, so money coming in, it sells for $2 per cup. Okay, what about the cost function? The rent is $120, and all of the supplies cost 50 cents for each cup. Okay, part A, write a linear cost function to produce X cups of lemonade. So the cost is going to be 50 cents for each cup, so 0.50X plus the fixed cost, which was $120. Okay, write a linear revenue function for selling X cups of lemonade. So for selling it, you sell it for $2 per cup. So the revenue function is $2 per cup, X cups, so 2X. I will write that. I'm just going to write 2X. Okay, now I want you to write a linear profit function. So remember that profit is equal to revenue minus cost. So your revenue is 2X, and your cost, you've got to put parentheses, is 0.5X plus 120. Okay, I tell you to put parentheses around your cost because you need to distribute this subtraction here. So 2X minus 0.5X minus 120, you get 1.5X minus 120. That's your profit function. Okay, how much profit will the vendor make if 50 cups of lemonade are produced and sold? It wants you to plug it into the profit function. It wants you to plug in 50 for X. So I'm going to type in on my calculator 1.5 times 50 and then minus 120. So on my calculator, I'm going to go to my home screen, and type in 1.5 times 150. No, hold on. I'm going to type in 1.5 times 50 minus 120. That looks better. 1.5 times 50 minus 120. And I get negative 45. So what does that mean in terms of this problem? It means that the vendor is in the hole $45. So it costs the vendor $45 to go make and sell those 50 cups of lemonade. Okay, in other words, there was no profit made. How much profit will be made for producing and selling 128 cups of lemonade? Again, I'm going to go to my profit function and plug in 128 for X. So I get 1.5 times 128 minus 120. And what number is that? So 1.5 times 128 minus 120 is 72. So what does that mean in terms of the problem? The vendor has made a profit of $72. Okay, the last thing says to determine the break-even point. Okay, break-even means where does the cost function equal the revenue function? In other words, break-even is when there's a profit of 0. You break even. Okay, I'm going to go over here to the left side. My cost function is 0.5x plus 120. And I want to know, when does that equal 2x? Okay, solving that equation for x, I'm going to add, I'm going to subtract 0.5x from both sides, minus 0.5x minus 0.5x. That's so I'm going to get my x's on the same side. When I do that, I get 120 equals 1.5x. 2x minus 0.5x. What is 2 minus 0.5? 1.5. Okay, now to get the x by itself, I need to divide both sides by 1.5. I will be left with x on the right-hand side, and on the left-hand side, 120 divided by 1.5 is 80. So the break-even point, when 80 cups of lemonade are produced and sold, the profit is 0. So the break-even point is 80 cups. Hopefully that example helped with the explanation of a linear cost, revenue, and profit functions. Until next time, take care.